Are there any more students to join? Yes, are there any more students to join? Anubhav, can you just confirm? Yes, I'm waiting for the response, students. Shall we start the class? Yes. Okay, Chetan, thank you.
I think now it's visible. Okay. So we all discussed about what's a linear transformation and how do you identify the given transformation is a linear transform, right? We stopped over there. Which are the examples we discussed for a linear transform? Can someone tell me which are the examples we discussed? Yes, please. Hmm. Which is the tell me the two trivial examples of a linear transform? We've got some messages here. One is your zero transformation, and the other one is the identity transformation. So we have seen how the identity and the zero transformation is represented. Yes, good, Krita. Okay. So now we will see some of the properties of the linear transformation, and then we will get back to the vector representation of it and so on. Okay. So now, so what is the first property is, so take the properties of linear transform. Properties of a linear transformation. First one is nothing but same as your zero transformation. That is, here instead of my vector 0, if I transform a zero vector, it would result in a zero vector. T of 0 is always equal to 0. Okay, that is the first property, and then we see that the transformation of a negative vector, that is t of minus v, is same as the negation of the transform vector v. So again I say here for all v belonging to the vector space v. Okay, then as we all have seen that whenever I say it's a linear transform, it preserves the additivity as well as the scalar multiplication. So the third property would be t of u minus v is equal to transformation of u minus transformation of v for all u comma v belonging to the vector space v. Okay. Then what is the fourth property? It's again related to it's a combination of the scalar multiplication as well as the addition. Okay, that means I can say if my vector v is a linear combination of the vectors v1 to vn, vector v is equal to c1 v1 plus c2 v2 plus c3 v3 and so on up to cn vn, then the transformation of v would be c1 into transformation of v1 plus C2 into transformation of V2, or I'll just take it in another step if you guys are getting confused. It is same as transformation of C1 V1 plus C2 V2 plus C3 V3, so on up to Cn Vn. And if I take it individually, it is C1 T times T of V1 plus C2 T of V2 and so on up to Cn T of Vn. Is it not the combination of both the scalar multiplication and the addition property of your vector space? Yes or no? So these are some of the theorems of the linear transforms. Any doubts with this? Any doubts, guys? Now we will see. So we all have seen that when I represent a linear system of equations, it's given by Ax is equal to B, right? We all have seen how I can represent a given matrix in the form of Ax is equal to B. So we will take that into a transformation and see what happens. So the difference equation Ax is equal to B. The difference equation Ax is equal to B and my vector equation A1x1 plus A2x2 and so on up to ANxn is equal to vector B, then so that is nothing but the matrix representation of this vector equation would be Ax is equal to B, as we have already seen. So where we can use this matrix equation, can someone tell me the applications of this? As you said already that I can use my linear system of linear equations in economics and also in the network flow diagrams, right? Now, so this can also be used in your application, computer graphics and DSP, because where it is nothing but a linear combination of the given vectors. Now I'll just say if I consider my matrix A to be a sum object, are you getting it? I'm considering this matrix A as an object which operates on the vector, okay? Or with an object which acts on a vector, an object which acts on a vector x, and A is an object which acts on a vector x such that when I multiply these two, it results in another vector Ax. Are you getting it? If you want, I'll be repeating it again. If they think that the matrix A as an object which is acting on a vector x, by multiplying it with x, it would result in another vector which is an Ax vector. Okay. So now let me consider another matrix, say a matrix A, which is 4, minus 3, 1 and 3, 2, 0, 5 and 1, and your vector x to be all ones. Can you tell me the matrix Ax? This is your A and this is your x. And similarly, I take again the same A, 4, minus 3, 1 and 3, 2, 0, 5 and 1, which is multiplied with a vector 1, 4, minus 1 and 3. Can you tell me the resultant vectors quickly? It is just the matrix multiplication. Yes. So if I assume this is of the form Ax is equal to B, tell me the B vector for both the cases. Yes, please. Five, eight. Chetan, what is the resultant matrix size, Chetan and Sinchana? 2 cross 4, and this is a 4 cross 1 matrix. So what will be your resultant? It is only a 2 cross 1. Why you people are getting a 2 cross? Okay, is it for both the answers you are giving? Chetan and Sinchana, ಎರಡಕ್ಕೂ ಹೇಳ್ತಿರೋದು answer. Okay, thank you. So the first one would be 5 and 8, and the next would be 0, 0. Okay. Now, can I say now, multiplying my vector x or multiplying my matrix A to the vector x transforms x into B. Are you getting it? Multiplying my vector x to the matrix A or multiplying by A transforms x into B. Can we say that? Multiplying A transforms x into B. Okay. So now, okay. So now can I say that it is also a linear transform? Multiplication by a matrix A is also a linear transform. Yes. And what I do, instead of representing all these vectors, I say those set of vectors which goes to 0 after multiplying it with A. So I say that it is transition of U into 0 vector. So that means when I say I'm multiplying my vectors with the matrix A, either it is transformed into a vector B in the domain, or it is resultant in a 0 vector. So all those vectors which goes to 0 vectors, I just say it is transition of U into a 0 vector. So if I try to represent that in a simpler manner, I just say if this is my set or a function and this, so these are the set of x vectors. Then I have a 0 vector and also the U vector. And I would get either B or a 0 vector. B can be again any 2 cross 1, 2 column vector. So I can say an x is multiplied by A. Since I don't have space, I'm writing it in symbolically. When x is multiplied by A, I would get the vector B. Whereas when U is multiplied by A, I get a 0 vector. So you can see here with this example, I can transform the vectors from one form to another form using matrix multiplication. Is it not? So I can say this is nothing but my transformation using, or the transformation of vectors. So this is nothing but my transformation of vectors in a transformation of vectors by matrix multiplication. Can we make the statement? Yes. You all agree with me? Good. Now we will see another important concept here. So we all saw that the difference equation of Ax is equal to b, where the Ax is equal to b can also be solved. So now, so we have seen it comparing to the same example. So solving for Ax is equal to b tells me that by multiplying all the vectors in R4, that is your transformation is from. So now can you define the transformation for this operation? Whatever we discuss, it is a transformation from R4 to R2. Is it not? I'm going from a 4-dimensional space to a 2-dimensional space. Right? Where your 4-dimensional space is a domain and your 2-dimensional space is a range. Domain. Okay, now, so I can say here the solution to this system of equation Ax is equal to b is all those vectors x which can be transformed to be in the range. Is it not? Yes? Are you understanding my statement? Fine. All the vectors x such that when I multiply it with a, it results in the vector a. So I can say the domain or the pre-image of the transformation is the solution to the system of equations Ax is equal to b, where A is your coefficient matrix and X is all those set of vectors. Yes? Any doubts with this? Now, so I can say I'm transforming my X into an Ax. Is it done? From X to Ax, either I call it as a transform or a function or a mapping. Both are all remains the same. So here I'm just trying to move from one set of vectors to another set of vectors. So now shall we generalize this statement to an m and n dimensional transformations? Is it clear till here? Everybody? Any doubts till here? Now, so if I say T is a transformation, if T is a transformation from Rn to Rn, if T is a transformation from Rn to Rn, is a rule, a transformation T from Rn to Rn is a rule that assigned to each vector in Rn, where a vector is T of x in Rn. Where a vector is T of x in Rn. That is, if it is your vector is x in Rn, then it is in Rn it would be the transform vector T of X. Okay, so that we will be seeing how the transformation is defined. So what is Rn and Rn? Which is the domain and the codomain? So this T of X is also called as image, codomain, and what else? It's also in the range, right? So I can say the set of all images of T of X is my range of the transformation. Okay, so we will be seeing what is the range of the transform again. So set of all vectors of T of X is the range of the transform. Say suppose I just give a representation of something like this. So if this is my vector X, and this is my range, say I assume now this it is in X is in Rn, and then if this is the range, say if I assume some space just for our convenience, okay, all Rn need not be in the range. Okay, your entire Rn need not be in the range. Only the certain set of vectors can be in the range. Say if I assume these are the set of vectors which are present in the range. So I can say if this is an Rn, this is my range. Like this, I apply the transformation, so I get it in the range, and here it has all T of X vectors. Any doubts? Yeah? Now, which is the domain and which is the codomain? Which is the domain and which is the codomain? Chetan, Sinchana, Lasita. Is the domain or the codomain? Rn is domain and your Rm is codomain. Correct? Now, so we have written the proof, right? We have written the properties of the linear transform. So can we prove the property of a linear transform? So I said these are some of the properties of the linear transforms, where I try to transform my given vector from one vector space to another vector space, right? So now let us try to prove those properties of a linear transform. So is it clear till here? If P is a transformation from V to W. Assuming V and W are the two vector spaces, which is the first theorem we saw. It's a transformation of a zero vector, right? So if I say transformation of a zero vector is equal to 0, I need to prove. What I do is I take the scalar multiplication of scalar multiplication, that is T of C into 0, and I assume my scalar is also a 0 value. So I get T of 0 times the 0 vector, so that is same as the scalar times T of 0. So what will be the resultant vector? Anything I multiply it with 0 will always be a 0 vector. And this is not that tough, right? Now, so this is the most simplest proof. So if I take 0 to be any vector, when I multiply it with the scalar multiplication of the vector, transformation is nothing but the scalar multiplied to the transformation of the original vector. That is what I did. I took the scalar value to be 0. 0 into transformation of 0 would be again resulting in a 0 vector. Okay? And then next, we'll see the other theorem. What is the other proof says? And yes, please. Which is the second property? Tell me the second property. T of minus V is equal to minus T of V. So is this difficult? T of minus V. So let me consider T of minus V. There's nothing but the transformation of minus 1 times V. So if we take the scalar outside, it is minus 1 times transformation of V. That is nothing but minus T of V. Okay. What about the third property? Please prove the third property. T of U minus V is equal to T of U minus T of V. So prove this property and show it to me. Yes. So you guys need to switch on your camera and then show me the answers. Whatever you have done. For the theorem, for this third property of the transformation. Do it fast. Yes, Rohit. Yes, please. Monisha. ಆಯ್ತಾ ಮಾಡಿ ಪ್ರೂಫ್ನ ಇಷ್ಟೊತ್ತು ಬೇಕೇನಪ್ಪ ಮಾಡಕ್ಕದ್ನ ಎಷ್ಟು ಟೈಮ್ ಇದೆಯತ್ತೆ not even 10 minutes not even 2 minutes sorry yes Shobit just at least tell me unmute your audio and tell me how did you do it ಹೇಗ್ ಮಾಡಿದ್ರಿ ರೋಹಿತ್ doing so the third property yes please ಆಯ್ತಾ ಇಷ್ಟೊತ್ತು ಬೇಕೇನ್ರಪ್ಪ ಮಾಡಕ್ಕೆ ಎರಡು ಪ್ರೂಫ್ ಮಾಡ್ತಿದ್ದೀರಾ ವಿನಾಯಕ್ ಶ್ರೇಯಸ್ Vaishnavi. ಹೇಳಿ ಅನುಭವ್ ಚಿಂತನ್ This is by the previous theorem 2, again T of U minus T of V. ಇಷ್ಟು ಮಾಡಕ್ಕೆ ಎಷ್ಟೊತ್ತು ಬೇಕಪ್ಪ ಮಕ್ಕಳ? Next. The last property I'll leave it to you as an exercise. Before coming to tomorrow's class, you guys can go through it and okay. Any doubts? Take down the problem. Let A be a matrix with 1, minus 3, 3, 5, minus 1 and 7, 1 minus 3, 3, 5 and minus 1 and 7, and B is a matrix with 3, 2 and minus 5, and B is a matrix with 3, 2 and minus 5. It's a column matrix, and U is again a column matrix with 2 and minus 1, and C is a column matrix with 3, 2 and 5. Defines a transformation from R2 to R3. Defines a transformation from R2 to R3 by T of X is equal to AX. T of X is equal to AX. Find T of U. I just write it here. Find T of U. That is the image of U. The image of U under the transformation. The image of U under the transformation. Second, find X in R2. Find X in R2 whose image, find X in R2 whose image under the transformation, is B. Find X in R2 whose image under the transformation is B. Third question, is there more than one X? Third question, is there more than one X whose image under the transformation is B? Find, is there more than one X in more than one x whose image under the transformation is B. And the fourth one, find find if find if C is find if C is in the range of transform. Find if C is in the range of transform. Okay. So here I've already defined the transformation to be T of x is equal to Ax. So now just simply find out the T of x is equal to Ax. That means take the matrix A 1 minus 3, 3, 5 minus 1 and 7. And how many vectors are there in the domain? There are only two elements in a vector because it is a two-dimensional space. That is, it is an R2. So I just take it to be x1 and x2. Okay. So simply multiply this matrix so that you determine the transformation in general. So I can take x1 minus 3x2, 3x1 plus 5x2 minus x1 plus 7x2. See, before I come to the next class, the fourth property needs to be proved. ನಾನು ಯಾರಿಗಾದ್ರೂ ಕೇಳ್ಬೋದು ಪ್ರೂವ್ ಮಾಡಿ ಅಂತ ಸರಿನಾ ಈಗ ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಏನ್ ಹೇಳುತ್ತೆ ಫೈಂಡ್ ದಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಆಫ್ ದಿ ವೆಕ್ಟರ್ u that is simple. So here I can say the transformation of u is nothing but matrix A into u, or I can just say it is AU matrix. AU matrix is nothing but 1 minus 3, 3, 5 minus 1 and 7. So I would get, which is multiplied with 2 and minus 1. So what will be the resultant matrix? Quickly multiply and tell me. 5, 1 and minus 9. Correct? Now, what does the second question part of the question say? Find out all those x values such that its image is B. So here I have a scenario where I have the similar to Ax is equal to B and solve for x. Is it not? If I compare that to a linear, this question, it is nothing but transformation of x is equal to b. When I say the transformation of x is equal to b, that is where my transformation is ax. So I get ax is equal to b and I need to find out x value. To find out x value, what I do is I can follow any method. I just take my matrix A, which is augmented with the matrix B, such that I get 1 minus 3, 3, 3, 5 and 2, minus 1, 7 and minus 5, and try to find out the solution to this system. Yes, quickly solve and tell me what is the solution for this? ಏನಾಯ್ತು solution? 2 ನಿಮಿಷ. Element to the elementary row operations, you will arrive at the solution. And one more thing, so if you have the online test, your internals to be conducted online with all your camera as your seniors took up their final examination. Is that okay? You guys don't have any network connectivity issue? And then also, you all have laptops? ಇನ್ಯಾರ ಹತ್ರ ಎಲ್ಲ ಲ್ಯಾಪ್ಟಾಪ್ ಇಲ್ವಾ? ಶಿವಕುಮಾರ್ ಹತ್ರ ಮಾತ್ರ ಎಲ್ಲರ ಹತ್ರ ಇದೆಯಾ? ಆಕಾಶ್, ಮತ್ ಕ್ಲಾಸ್ ಎಲ್ಲ ಹೇಗ್ ಮ್ಯಾನೇಜ್ ಮಾಡ್ತಿದ್ದೀರಾ? Network issue is there. Okay. Network issue. ಎಲ್ಲಿರೋದು ನೀವು ಬಿಜ್ವಲ್? Sometimes go out of the class due to network issues. Wayanad. Okay. ನೀವೆಲ್ಲಿರೋದು ರೋಹಿತ್? ಶಿವಕುಮಾರ್? ವಿಜಯಪುರ. ನೀವು ಶಿವಕುಮಾರ್? ಅಲ್ಲಿ ಯಾವ್ದು ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಹಾಕ್ಸ್ಕೊಳಕ್ಕಾಗಲ್ವಾ ನೀವು? ಯಾಕಂದ್ರೆ ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಹಾಕೊಂಡ್ರೆ ನಿಮಗೆ ಸ್ವಲ್ಪ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಪರವಾಗಿಲ್ಲ. ನೋ ವಿಲೇಜ್. ಎಲ್ಲಪ್ಪ ಅನ್ಸ್ಟೇಬಲ್ ನೆಟ್ವರ್ಕ್. ಅದನ್ನೇ ನಾನು ಕೇಳಿ, ಯು ಆಲ್ ಆರ್ ಯೂಸಿಂಗ್ ವಿತ್ ಯುವರ್ ಮೊಬೈಲ್ ವೈಫೈ ರೈಟ್? ಹೊನ್ನಳ್ಳಿ, ದಾವಣಗೆರೆ. ಸೊ ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಇಲ್ಲ ಅಂತೀರಾ? ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಹಾಕ್ಸ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಇಶ್ಯೂ ಆಗದೆ ಇರೋದು ಮೊಬೈಲ್ ನೆಟ್ವರ್ಕ್ ಬಿಟ್ಬಿಟ್ಟು. ಬಟ್ ಅಲ್ಲಿ ಫೀಸಿಬಿಲಿಟಿ ಇದೆಯಾ ನಿಮ್ಮ ಮನೆ ಹತ್ರ? ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. Because they are planning to give you guys the exam as they give the internals as we did the examination for the HL students. Sure. Sayed ನೀವಿರೋದಲ್ಲಿ ಸೈಯದ್ ಚಿಂತನ್ ಸಕಲೇಶ್ಪುರ. ಚಿಂತನ್ ನೀವು? ಹಾಸನ್. ಹಾಸನಲ್ಲೆಲ್ಲ ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಇದೆ ಅಂದ್ರಪ್ಪ, ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಯೂಸ್ಕೋಬೋತಾನೆ ನೀವು? ಎಲ್ಲೆಲ್ಲಿ ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಫೀಸಿಬಿಲಿಟಿ ಇದೆಯೋ ಅಲ್ಲಿ ನೀವು ಬ್ರಾಡ್ಬ್ಯಾಂಡ್ ಹಾಕೊಳ್ಳೋದು ಒಳ್ಳೇದು. ಯಾವ್ದೆಲ್ಲ ಕೇದಾರ್? ಏರ್ಟೆಲ್ ಅವರು ಎಷ್ಟೆಲ್ ಅವರೆಲ್ಲ ಬೇಗ ಕೊಡ್ತಿದಾರಲ್ಲ, BSNL ಡಿಲೇ ಆಗ್ತಿದೆ ಅಷ್ಟೇ. ಎಲ್ರಿ ನಿಮ್ಮನ್ನ ಮೈಸೂರಲ್ಲಿ? BSNL is not working properly. ಬನ್ನಿ ಅಂತ. Then you can go for Airtel or Airtel broadband services is also good, right? Airtel, Yashtel. Here. ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಬೆಟರ್ ಅನಿಸುತ್ತೆ. Now ಎಷ್ಟು ಹಾಕ್ಸ್ಕೊಂಡ್ವಿ ರೀಸೆಂಟ್ ಆಗಿ ಇಟ್ಸ್ ಬೆಟರ್. Okay. Yeah, still installation is 3,000, but it's a one-time investment, right? There. It's better, Shreyas. I'm taking my class with the Estel network. Whenever I take my class from home, I'm using Estel. With the mobile data, it is tough, but with the Estel, it's okay. I'm able to handle class. Disconnect and Artina. Okay, now we'll discuss about that later. Okay, so what is the solution for this? But better, I think, the other services answer. But you need to check. What are the values of x1, x2? Oh, precious. Yes, tell me what are the x1, x2 values? X1 will be 3 by 2 and x2 is minus half. Correct? Now, okay. Yes, what happened? I'm not getting any answers. So, okay, I'll convey your messages, whatever you have given to me now. So, we'll see what best can be done. Okay. So, most probably you'll be having it online. And then for the network issue, you will need to do some alternate arrangement, I guess. Anyway, I'll give the feedback of whatever you have done. Fine? So come back to the class. Now what is the third question says? Is there more than one x whose image under T is B? That means, is there more than one x value? So in the unique solution, multiple solution, you get a unique solution or the multiple solution. You receive the unique solution, is it not? X1 is 3 by 2 and x2 is minus half. So since I have got a unique solution, this is for part C, this is for B and this is for A. So since I have got a unique solution, there is only one x whose image is B. Okay. What is the fourth part of the question? Find if the vector C is in the range of the transform. So to check whether it is in the range of the transform, I should check if I get Ax is equal to C, then I can say that C is in the range of my transformation. So check whether you get Ax is equal to C How do you check whether you get AX is equal to C? Yes, please. How do you check whether you get AX is equal to C? So we have already obtained the AX matrix. X1 minus 3x2, 3x1 plus 5x2 minus x1 plus 7x2 is equal to 3, 2 and 5. Right? So I get it as 3, 2 and 5. And when I equated it, it's again a system of linear equations, is it not? So I get a system of linear equations with x1 minus 3x2 is equal to 3, 3x1 plus 5x2 is equal to 2 and minus x1 plus 7x2 is equal to 5. If I am able to find out the x1 and x2 values, that is if this system is consistent, then I can say the vector C is in the range of the transform. If the solution exists for this, then I can say the vector C is in the range of the transform. So take down the matrix 1 minus 3, 3, 3, 5 and 2 minus 1, 7 and 5. So solve this and tell me the final matrix quick. I'll just give you 2 minutes time. Big fast. Yes, tell me the answer. Are you guys there? What is the final matrix? Okay, tell me what are the row operations you are doing? R3 plus R1, R2 minus 3R1, and then after this I'll perform R3 by 7 and R4 by 4. Later, the last operation what I do is R3 minus 2R2. So that will result in 1 minus 3, 3, 0, 2 minus 1, 0, 0 and 3. Now with this resultant matrix, now tell me, is your system consistent or inconsistent? Yes? Is your system consistent or inconsistent? It is inconsistent. So when this system is inconsistent, now I can say that C. So since the system is inconsistent, that is, when I say that there is no x values such that when I multiply it with the matrix K, I get the C. There are no x values such that when I multiply it with matrix A, I get C value. So I say now, since it is inconsistent and C is not in the range of the transformation. C is not in the range of the transformation. Any doubts? Is it clear? ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ರಿಗೂ? ಬೇಗ ಬೇಗ ಹೇಳಿ ಅರ್ಥ ಆಗಿದ್ಯಾ ಅಂತ. Yes. If you all have understood, then we'll wind up today's class and then we'll continue on. I think next I have your class on Tuesday again, right? Tuesday or Monday? Monday I have your class at 3:30 to 4:30, which is your tutorial session. So we'll try to solve some problems and then cover the concepts also. Okay? So if you don't have any doubts, and then we can wind up today's class. Thank you.